Hi guys, welcome back to my YouTube channel. Today we want to find the possible value of x given that you have this quantic equation x plus 1 all in bracket is to the power 4 plus open bracket x plus 3 all in bracket is to the power 4 equals 16. So guys, let's see how to solve this problem easily by saying solution. So from here we have x plus 1 raised to the power 4 plus x plus 3 raised to the power 4 equals 16. Now to solve this, we can say let y to be equals x plus 1. And from here, when y equals x plus 1, we can now have our x to be equals y minus 1. That means anywhere we see x, we can substitute it as y minus 1. Anywhere we see x plus 1, we can substitute it as y. Now from here, this implies that we are going to have this to be y all raised to the power 4 plus, from here we have it to be y minus 1 plus 3 all raised to the power 4 to be equals 16. So now guys, from here we are going to have it to be y raised to the power 4 plus this we have it to be y minus 1 plus 3 will be equals 2, then raised to the power 4 equals 16. Now from here, to expand this, we have to recall from Pascal triangle. To expand this one, let us use Pascal triangle. And to use this Pascal triangle, we can recall that for the first one, we have it to be 1. Then the second one will now be 1, 1. Then this one will now be 1. This one will be 2. Then this one will now be 1. Then the other one will be 1. This one will be 3. This one will also be 3. Then we have another one to be 1. So for this one will be 1. Then we also have this one to be 4. This one will now be 6. This one will now be 4. Then this one will now be 1. Now, how do we guess this? Once you have the first one to be 1 here, that is when the power is equals 0, then to get this one, you say 0 plus 1, we have it to be 1. 0 plus 1 here, we have it to be 1. Now, from here as well, when you say 0 plus 1, we have it to be 1. 1 plus 1, we have it to be 2. 1 plus 0, we have it to be 1. Now, likewise, from here, you say 0 plus 1 will be 1. 1 plus 2 will be 3. 2 plus 1 will be 3. Then 1 plus 0 will be 1. Now, from here, you start from here. 1 plus 0 will be 1. 1 plus 3 will be 4. 3 plus 3 will be 6. 3 plus 1 will be 4. 1 plus 0 will be 1. And simply, this one is for the when the power is 0. This one is when the power is 1. This one is when the power is 2. This is when we have power to be 3. This is when we have power to be 4. And mind you, from here, we have our power to be equals 4. So now to now expand this one, we are going to have it to be when you have y plus 2 raised to the power 4. First of all, when this one is increasing by y raised to the power 4, then we are going to have it to be 2 raised to the power 0, which equals 1. Plus when this one is y raised to the power 3, then we are going to have our 2 raised to the power 1. Then when you have this one to be y raised to the power 2, then we have our 2 raised to the power 2. Again, when you have y raised to the power 1, then we have our 2 raised to the power 3. When also we have y raised to the power 0, we have our 2 raised to the power 4. So the fact there is that when this one is increasing, then the other one will be decreasing. And from here, when this one is increasing, this one is decreasing. So from here, we have y raised to the power 4 plus this will be 2y cube plus this one will now be 4y squared then this one will now be 8y plus this one is 1, 2 raised to the power 4 is 16. Now guys, so from here we have this to be y plus 2 raised to the power 4 to be like this. Now by using this coefficient that we have here, then it implies that we are going to have this one is 1 multiplied by this, we have it to be y raised to the power 4 plus this one is 4 multiplied by 2, here we have it to be 8y cube plus this one have 4 here multiplied by 6, we have it to be 24 y square plus this one is 4 here multiplied by 8, we have it to be 32 y, then this one is 1 multiplied by 16, we have it to be 16, which means we have our y plus 2 raised to the power 4 to be equals this. When this equals this, now let us go and substitute this one here. Then we are going to have everything to be equals y raised to the power 4 plus this y raised to the power 4 plus 8y cube plus 24y squared plus 32y plus 16. Then we have everything to be equals 16. From here we have everything to be equals 16. So therefore, obviously this 16 will cancel this 16. Then we are going to have it to be y raised to the power 4 plus y raised to the power 4 plus 8y cube plus 24y squared plus 32y equals 0. Now we have y raised to the power 4 plus y raised to the power 4. You can easily have this to be 2y raised to the power 4 plus 8y cube plus 24y raised to the power 2 plus 32y equals 0. Now, mere looking at this, we have 2 in common and we have y to be in common. So we can factor it out and this will now be 2y into, now this one will now be y raised to the power 3 plus this will remain 4. When you factor 2 out from here, then this divided by y, we have it to be y squared plus, now 24 divided by 2, we have this one to be 12. Now y squared divided by y, we have it to be y plus 32 divided by 2, we have it to be 16. Y divided by y, we have it to be nothing. Then we have everything to be equal 0. So from here, it is obvious that we have 2y to be equal 0, or we are going to have this expression to be y raised to the power 3 plus 4y squared plus 12y plus 16 to be equal 0 before this expression can be satisfied. Now, if y2 minus y equals 0, from here, by dividing both sides by 2, this will take away this, then we have our y to be equals 0. Now, if our y equals 0, we have to recall from here that we have y to be equals x plus 1, and easily we can get from here y to be equals x plus 1. Then y equals 0 from here, we have x plus 1 to be equals 0, which we have x to be equals minus 1. So therefore, the first roots of this problem equals minus 1. That means we have it to be x1. Now, to get other roots from here, we are going to apply the synthetic division approach. Synthetic division approach. Now, what do we mean by this synthetic division approach? Is by we be guessing any number, okay, assuming when y equals -2, if it will satisfy this expression that once we substitute the value of y, it will give us 0 at the right hand side to make it equal to the left hand side. Now let's test. Then from here we are going to have it to be -2 raised to power 3 plus 4 into -2 raised to power 2 plus 12 into -2 plus 16. Then are they going to give us 0? So from here we have this to be, we have minus, then when you have minus raised to power 3, we have it to be -2 raised to power 3, we have it to be 8. Then we have this to be minus raised to power 2, we have it to be 2 plus, then 2 raised to power 2, we have it to be 4. 4 times 4, we have it to be 16. Then plus, sorry, we have this one to be minus times plus times minus will be minus. 12 times 2 will be 24 plus 16. Then are they going to give us 0? Now from here, we have 16 plus 16 will be 32. Minus 8 minus 24 will be minus 32. This plus this, we have it to be plus 32, which equals 0. So this expression is true for the value of y equals -2, which means that we have y to be equals -2, but recall that we have our y to be equals x plus 1. So when we have y to be equals x plus 1, this implies that x plus 1 equals -2, and we have our x to be -1 minus 2, which means we have x2 to be equals -3. So we got the second root for the problem. Now let's see how to get the other roots. So now we have our x1 to be -1, x2 to be equals -3 from this y equals -2. Now let us recall from here. When we recall from here, we have y raised to power 3 plus 4y squared plus 12y plus 16 to be equal 0. Now from here, to further apply the synthetic division approach, we have to recall from this -2 that we have here, and we are going to apply the method as follows. You first of all have this. You have our -2 here. Now, what are the coefficients of this? We have it to be 1, 4, 12, and 16. Now we have to do this. Then we take back our 1 here. Now, the next thing is -2 multiplied by 1, we have it to be -2. Now, we have to add this one together. 4 plus -2, then we are going to have this one to be 2. Now, -2 multiplied by 2, we have it to be -4. Then when you add this one together, we have it to be 8. Secondly, -2 multiplied by 8, then we have it to be -16. Now from here, when you add this one, we have it to be 0. Then we call this remainder. Now, in this case, that means we've used the second root to reduce this root to the power 2. That means we have this one to be y squared plus 2y plus 8 equals 0. This is the new quadratic equation we have from here. And we can solve this using quadratic method by saying we have our a to be the coefficient of y squared to be equals 1. Then our b will be equals 2. Then our constant value will be equals 8. Now, if that should be the case, we can now recall from y to be equals minus b, positive or negative, square root of b squared minus 4ac, then all divided by 2a. So, from here we have our b to be equals minus 2, positive or negative, square root of 2 square will be 4, minus 4 multiplied by our a is 1, then our c equals 8, all divided by 2 multiplied by 1. Then from here, we are going to have this to be minus 2, positive or negative. This multiplied by this will be 32, minus 32 by what? 4 minus 32, we have it to be square root of minus 28 divided by 2, which implies that we have our y to be equals minus 2, positive or negative, square root of 28i, then divided by 2. Now, when you simplify this square root of 28, we are going to have this to be minus 2, positive or negative, then square root of 2 root 7i, then divided by 2. So from here, obviously, we can have our y to be equals this divided by this, we have to be minus 1. This cancel this, we have to be positive or negative, square root of 7i. And we have to recall that we always have our y to be equals x plus 1. Now, this will be second root and fourth root. Now, when we have this to be x3, will be equals minus 1 minus 1. Then when we take plus, will be plus square root of 7i. Then this will be minus 2 plus square root of 7i. That is our x3. And likewise, to get x4, since we now be minus 1 minus 1, then we take this minus square root of 7i, then this one will now be minus 2 minus square root of 7i. That's our x4. So we can finally declare that we have x1 to be equals minus 1, x2 to be equals minus 3, then x3 to be equals minus 2 plus square root of 7i, then x4 to be equals minus 2 minus square root of 7i. So now to check, we can recall from here. So to check, we have to recall that we have x plus 1 all raised to power 4 plus x plus 3 all raised to power 4 equals 16. Now, when x equals, let's test for the complex value. So for resolution, we have our x1 to be equals minus 1 and x2 to be equals minus 3. So then we are going to have this to be, when x equals minus 1, let's test for this. Then we are going to have this one to be minus 1 plus 1 raised to power 4 plus minus 1 plus 3 raised to power 4. Are they going to give us 16? From here we have 0 raised to power 4 plus this one will now be 2 raised to power 4, which equals 16. So this is true. Now when x when x also equals minus 3, what will happen will be minus 3 plus 1 raised to the power 4 plus this will be minus 3 plus 3 raised to the power 4. Then is it going to give us 16? So from here we have this to be minus 2 raised to the power 4 plus this one will be 0 raised to the power 4. Then are they going to give us 16? So this one will be plus 2 raised to the power 4, which equals 16. This is also true for the value of x equals minus 3. So if you are new here, once again, don't forget to share, like, comment, and subscribe to my YouTube channel for more mathematics tutorial videos. Bye bye.